This is the review for Unit 7, Logarithms. In the first 3 questions, all it asks for whether or not this is an increasing or decreasing exponential growth or decay function. And if you look at the base of the exponent, that will tell you whether or not it's growth or decay. If the term that is being raised to the exponent is greater than 1, it's always going to be growth. So this is a growth, and it's a 50% increase because it's 0.5 over 100%, so that's 50% growth. Okay, over here, our base of the exponent is 2, so that is a whole 1 over 100%. So this is a growth, and it's growth of 100%. Remember, it's growth over 100%, so that's why it's 100% growth. And then 3/4 is converted to 0.75, so that is a decay, exponential decay function. And how much below 100% is 75? That's how you determine the decay percent, and that is going to be 25% decay. Okay, going on to number 4. This is continually compounded continuously equation, A equals PERT. The P is the principal. The principal is the amount you put into the account. E is just the number E, which is 2.7 approximately, and it's found in the calculator. And you raise that E raised to the rate times time exponent. So the important thing is here that you put it in your calculator correctly with the correct parentheses. So we'll substitute in PERT. So we're going to put in the amount of 400, so that's your principal. E raised to the rate times time. We can change 3.5% to 0.035, and we have to multiply for 5 years, so we're going to multiply times 5, and the parenthesis has to go outside both of those numbers. Okay, so when we put that in your calculator, you're going to enter 400, and then you're going to take the e to the x key and raise that to the 0.035 times 5 and hit enter, and it's $476 and approximately 50 cents. Now you always want to write this in money, so keep your decimal point rounded to the nearest hundredth because we're dealing with money here. So $476.50. Okay, for number 5, it says you buy a new car for $18,000. The value of the car decreases by a rate of 15% each year. The exponential decay model is given for you. It's right here, y equals a times 1 minus r to the t power. T is the number of years since you bought the car, and a is the initial amount. Determine the value of the car after 3 years and then after 5 years. So this one, you already have the equation. We're just going to substitute in all the parts. 1 minus rate to the time. Okay, so A says is your initial amount. We bought the car initially for $18,000. So we'll substitute $18,000. 1 minus your rate. The depreciation rate is 15%. So 1 minus 0.15. And we want to know for after 3 years for this first situation, so we'll raise it to the 3rd power. We can put this into the calculator. 18,000 parentheses 1 minus 0.15 enter parentheses raised to the 3rd power for 3 years, and you can get your value is $11,054.25. And that's how much the car's worth after 3 years. So we can do the same thing for 5 years. Just substitute in $18,000 for the original amount 1 minus 0.15 raised to the 5th power. And we can then put that into the calculator again and hit second entry, because the only thing we're changing is the 5 years, so we can go back over the 3, change that to a 5, and we can get what it's worth after 5 years. $7,986 and approximately 70 cents. Okay, and then for 6, 7, and 8, it says we have to write the equation in exponential form. So when you're in log form, the base of the exponent is the base of the log. So 2, this is your answer, this is your power, the BAP. Base, answer, power. Base, answer, power. So 2 is the base, the power is 6, and the answer is 64. And as you know, 2 to the 6th is 64. Okay, over here, log base 3 of 1/9 equals -2. So 3 is your base. This is your answer, 1/9, and your power is -2. And you know that 3 to the -2nd is 1/9. And then this one, 2 is the base, the power is 0, and the answer is 1. And you know 2 to the 0 is 1.